In question number 9, we're asked to find, we're given the graph of f prime. So this graph is f prime, and that we need to find the local max coordinate and find out where it occurs. We also need to find the inflection point, and then thirdly, when we're given f of 0 equals 1, we want to find the actual y value of the maximum. Okay, so part 3 is going to involve the fundamental theorem of calculus. For part A, part 1, determining the local max coordinate, we just need to look at the slope values or the y values of the slope equation. So where I want to see where the slope changes is where it hits zeros. Okay, so where it hits a 0 is here, here, and here. Okay, so at 0 we have 0, at 3 we have 0 slope, and at looks like 5.5 we have 0 slope. If I test the slopes in there, I have positive in this region. Okay, so that would be a local min. That's a local max. Between 3 and 5, I have negative y values, which means negative slope. So that's probably a local min. And then on the right side of 5, I have positive y values, which indicate positive slope, which is that. So I'm just looking at the actual y coordinates, if it's above or below, to determine positive or negative slope. Now, I want to find the local max. Okay, so local max is going to go from positive to negative slope. So local max coordinate is going to happen here. Okay, so just get rid of that little extra thing here. Local max coordinate happens when we go from positive to negative slope. It's going to be on that point on the graph. So local max, so for part 1, local max is at x equals 3. So the x coordinate of the inflection point now, we need to look at the second derivative. To get an indication of second derivative, we look at the slope on the slope graph. So where it changes slope are potential points of inflection. So in yellow there, okay, so what we're looking at is here, the second derivative. In yellow, we can see that there is a change in direction there. Now, it's not a 0 slope, so it is an abrupt change, so that's an undefined second derivative. And at x equals 5, there again is an abrupt change, so but that's a change in direction. So if I have a change in the slope of slope, means I have a change in concavity. So this positive slope here in this section means I have positive concavity. Okay, so here I also have positive slope. So in this section here, I have positive slope or positive concavity. And in between these 2 points, okay, it's negative slope. So I have negative concavity. So it's going to be upside down. Okay, so I have this negative concavity happening in that section. So then the x coordinates of the inflection points, okay, so the inflection must occur at x equals 1 and 5. Now there has to be a change of concavity for there to be an inflection, so I have to make sure I check the concavity when I do that. The last part is using the fundamental theorem of calculus. If I know that at 0, the y coordinate is 1, so I'm going to make a table of values here. At x is 0, y is 1. Well, I know there's a positive displacement from 0 to 3 because I have positive slope. So all this represents positive displacement. In fact, the area under that curve represents the displacement on the original y function. So calculating that area, so this area I call area 1. Okay, we have a base, it's a triangle with base 3, height 2. So 2 times 3 divided by 2 gives me 3. So at x equals 3, I know I've gone plus 3, so my y coordinate is now 4. Okay, so the area is positive 3. And that actually, I think that's what we're looking for. The question asks for find the absolute value of the absolute max. So max is going to happen at x equals 3. So using the fundamental theorem of calculus, I just find the coordinate, the y coordinate, when x is 3. So the absolute max, so part 3 of this, the absolute max is at x is 3, y is 4.